Let us see about Tdma. Tdma is nothing but time division multiple access. Imagine a group of friends sitting around a dinner table, all wanting to share their day. If everyone talks at the same time, it's just a chaotic wall of noise. No one understands anything. To solve this, they agree on a simple rule. Everyone gets exactly 1 minute to talk, one after the other, in a strict circle. Ali speaks for 1 minute, then Babu speaks for 1 minute, then Charlie speaks for 1 minute. Once everyone has had a turn, it loops back to Alice. This is exactly how Tdma works in wireless communication. Tdma. It stands for Time Division Multiple Access. It's a technology used in digital wireless networks like older 2G cellular networks to allow multiple users to share the exact same radio frequency channel without interfering with each other. Instead of dividing the channel by frequency, like different stations on an FM radio, Tdma divides the channel by time. Now, let us see how it works. Suppose there are four users A, B, C, and D. The available time is divided into four equal slots. Slot 1 will be used by user A, slot 2 user B, slot 3 user 4, slot 4 user D. After slot 4 again the sequence starts. Okay. So to manage the sharing of time, Tdma organizes transmission into a continuous stream of frames. Each frame is sliced into tiny fractions of a second called time slots. Each frame is sliced into tiny fractions of a second, which is called time slots. Then the allocation. Every active phone or device on the network is assigned a specific time slot in the frame. The burst. When your phone wants to send data, like your voice during a call, it waits for its designated time slot. When that microsecond arrives, it transmits its data in a quick burst, then goes quiet. The cycle. The network quickly moves to the next user slot and the process repeats. This cycle happens hundreds of times per second. So, to human ears, the conversation feels perfectly continuous and uninterrupted. Imagine a single radio frequency divided into three time slots, user 1, user 2, and user 3. 0.01 to zero point zero 0.02 seconds, user 1 will be transmitting a tiny piece of user's one's voice is heard by the network. Then from 0.02 seconds to 0.03 seconds, user 2 will be transmitting and a tiny piece of user's 2's voice is heard by the network. From 0.03 seconds to 0.04 seconds, user 3 will be transmitting. Network will hear a tiny piece of user's third voice. From 0.04 seconds to 0.05 seconds, user 1 will be transmitting, that is cycle repeats. The next piece of user's one's voice will be heard by the network. Then why we have to use Tdma? Since that is advantages, no need of there is no interference because devices never transmit at the exact same instant. Their signals don't crash into each other. And also extended battery life, since your phone only transmits during its specific time slot and rests during the others, it saves a significant amount of battery power when compared to constantly transmitting. And also it is cost effective. Multiple users share a single piece of radio hardware at the base station, making the network cheaper to build and maintain. Because signals traveling from different distances might arrive slightly late. Tdma requires tiny buffer of absolute silence between slots known as a God period. If the devices are not perfectly synchronized, then the time slots could overlap, leading to dropped data. Disadvantages requires accurate time synchronization between users. If one user has no data to send, its assigned time slot may be wasted, more complex than simple access methods due to time slot management. If you see the applications of TDMA, it is used in 2G GSM mobile communication, digital cellular networks, satellite communication, wireless communication systems, public safety communication systems. Each user occupies cyclically repeating time slot. TDMA systems transmit data in a buffer and burst method, thus the transmission for any user is non-continuous. Digital data and digital modulation must be used with TDMA. TDMA scheme where each channel occupies a cyclically repeating time slot. This is the frame structure. It consists of number of slots. Each frame is made up of preamble, an information message and trial bits. Preamble contains the address and synchronization information that both the base station and subscribers use to identify each other. God times allows synchronization of the receivers between different slots and frames. Efficiency of TDMA system efficiency, it is a measure of percentage of transmitted data that contains information as opposed to providing overhead for the access scheme. The frame efficiency is the percentage of bits per frame which contain the transmitted data. The number of overhead bits per frame is given as this, where NR is nothing but number of reference burst per frame. This NT number of traffic burst per frame. BR number of overhead bits per reference burst. BP number of overhead bits per preamble in each slot. G number of equivalent bits in each God time interval.